Hey, how are you guys doing? Welcome back. I just wanted to take a few minutes and try something. I was recently helping a couple of people take their first steps in learning how to program. They're trying to teach themselves, and I ran them through a couple of exercises and sort of left them with a roadmap on where to go. And one of those exercises in particular they said was really useful. So I wanted to try to take it to a bigger audience and see if anyone else finds this useful. I'm really kind of hoping the answer is yes. But this is really aimed at anyone who is just started out learning how to program and wants a good exercise to hone their skills. Especially if you're self-taught, this is going to really give you guys a pretty good sense of direction on where you're going. And if you're not learning how to program and you're just generally curious what it's about, this is also probably a good exercise for you because you can do it relatively quick and it'll give you a good idea if this is something you're interested in pursuing any further. Before we jump into the exercise, I want to take a minute or two and really frame out what it is we're trying to do and why we're doing it. This exercise focuses entirely on logic and pretty much not at all at writing code. And writing code is really important. Like once you guys become bigger, stronger developers, you're going to want to really learn the ins and outs of a language, which will tell you what problems that language is really suited to solve. But until you get there, logic is the fundamental of programming. Right? Programming is all about taking problems and breaking them up into smaller problems or hopefully usable steps. A good analogy is if I showed you guys this shape and told you to describe it to someone who had never seen it before, it would be kind of challenging to figure out where to start. But if we look closer, that shape is actually composed of a whole bunch of smaller shapes that are a lot easier to convey. And that's exactly what programming is doing. We're just not taking a shape and breaking it up into visually smaller shapes, we're taking a problem and breaking it down into logically smaller problems, but it's pretty much the same process. The running joke is that learning how to program is learning how to Google, and if you go to Google with problems that look like, how do I repeat a block of code multiple times, or how do I tell if a number is even or odd in Python, that's going to be a whole lot easier, and you're going to get a whole lot more useful results than if you just go to Google with your entire problem and basically type in, hey Google, how do I build Fortnite in C++? Because you're not going to get a lot of help. And rightfully so. The other thing too is if you do this early on, you'll avoid a very common pitfall. A lot of people very successfully learn their first programming language and then have a very hard time transitioning to other languages after that. They'll learn JavaScript or Python or whatever have you. They might go learn C++ or Java or C#, and they're very good at taking a problem in their head and breaking it up into that specific language. And it's just kind of a stream of consciousness for them. They could take a problem and write it into code and take a problem and write it into code. And then the problem is when you sort of yank the carpet out from under them and tell them to go write it in something else, they don't have a lot to work off of. Which is why I think breaking it up into two distinct steps is really, really gonna help. Because if you could focus on break the problem up and then write it into code, the second half, like I said earlier, is pretty much just a few Google searches. So with all of that in mind, let's jump into the exercise. Okay, so the first thing you're gonna wanna do is take whatever space you have available to work with and divide it down the middle so that you have a left half and a right half. Again, I would highly recommend doing this the first couple times on a whiteboard if you have one available to you, but if you don't, computer screen will work totally fine. Obviously, I'm doing this on a computer monitor. Turns out it's a whole lot easier to just capture your desktop than it is to actually record a glossy whiteboard. All of that aside, we're gonna start with the left side, which is gonna be our data. This is sort of our working space, but I've given special attention to what we are given and what we are giving back. A lot of programming is broken up into these sort of data pipelines of you're gonna take something in and give something out, and then we're just gonna chain a whole bunch of those things together. So separately, I might have a function that takes the location of a file and spits out its contents, and I might have another function that takes the contents of a file and actually filters it down to the meaningful bits of information that I want. And separately, they're useful, but if I put them together, I can give the first one the location of a file, who passes the contents to the second guy, who gives me the actual bits and pieces of information that I was looking for, which is a whole lot more useful. So there's a lot of special attention given to what you are given and what you are giving back. On the right half, we're going to focus on the actual stuff that we're doing. So I've worked out an example problem a couple of times. The problem we're going to use is the collat sequence. So basically, you start with a number, and then if it's even, you divide it by 2, and if it's odd, you multiply it by 3 and add 1, and you repeat that process until you get 1. And working a couple of examples is a really good way to get you in the right frame of reference to solve the problem, because it first and foremost establishes your dominance over the problem. You've proven that you can solve it, and therefore you're qualified to teach a computer how to do it, because if you can't work it yourself, then it's probably not going to go very well when you try to teach a computer how to do it. The other thing it allows you to do is be really introspective. So if you ever find yourself getting stuck and you don't know what to write to solve a problem, go to a whiteboard and work the problem. And you'll either find that you can't work the problem, which means that you need to learn something, or you can work the problem, at which point you actually know what to do next. You just need to figure out what you're doing and why you're doing it so that you can put it into code. And then down here is the actual procedure, which is just going to be a whole bunch of numbered steps in plain English. So, like I said, we're doing the colettes sequence, so we have to have a starting number. That's going to be a given, so I'm going to write it down here. All right, we have a spot to put our starting number. I also want a spot to work with it, because variable names are really important. And if I called this starting number, but then it also eventually became all of the other numbers, it wouldn't really be a good name. And if I just called it number, that's kind of equally bad. So in the procedure, step 1 is going to be put the starting number into the current number. Okay. Step 2 is going to be to basically, if the current number is even, divide it by 2. If the current number is odd, multiply it by 3 and add 1. And that's great because we can put 4 in our starting number and say, put the starting number to the current number. Boop. If the current number is even, divided by 2, it is done. If the current number is odd, multiply it by 3 and add 1. It's not, and that's it. So we never actually reached 1, and we know that we always want to keep going until we reach 1, so I'm literally going to write until the current number is 1. And then I'm just going to take all of this and sort of indent it in with sub-steps to note that this is what we want to repeat. And we'll try this again. So we'll start with 4, and we'll put 4 into the current number, and until the current number is 1, which it's not yet. If the current number is even, divide it by 2. Done. If the current number is odd, multiply it by 3 and add 1. It's not odd, we don't have to do anything. Sadly, it's also not 1, so we start over. If the current number is even, divide it by 2. Okay, 2 divided by 2 gets us to 1. And if the current number is odd, multiply it by 3 and add 1. So we multiply 1 by 3 to get 3, and then add 1 to get 4. And we reach this guy, which is unfortunate because I was actually hoping that when we got to 1, we would be done. So I'll write otherwise. And we'll do this again. So again, you are the computer. You have to follow your instructions as literally and as to the T as possible. So starting with 4, we put the starting number into the current number. All right. The current number is not 1. So if the current number is even, divide it by 2. Okay, 4 divided by 2 is 2. We don't have to do the other part. It's not 1 yet. If it's even, divide it by 2. And then we don't have to do this part. And now it is 1, and we're done, which is awesome. Unfortunately, we didn't actually draw anything because, like, if you're in the Matrix, you might just see a whole bunch of random floating boxes with numbers flickering in and out of them. But realistically, that's not how anybody uses a computer, short of some very extreme exceptions. Normally, programs have to go through, like, an extra step to actually deliberately show us something useful. Because especially in bigger programs, you might have hundreds of millions of boxes, and only a handful of them are actually what the user wants to see. So we are going to specifically code what we want to display and when. So we can display the current number at the end of every loop. And then I'm just gonna have an output down here, and we'll start over. Put the starting number into the current number. Okay, till the current number is 1, which it's not. If it's even, divided by 2, we can skip B and then display it. All right, and then we start over until the current number is 1. It's not 1. If the current number is even, divided by 2. Okay, we don't have to do B. We can display it, and then we're done because we hit 1. Notice how we didn't actually display 4 though. We didn't display 4, 2, 1. We only displayed the 2 and 1. So we are going to, off the bat, display the starting number. And then that should get us to a point where we'll start with 4 and display it. Put the starting number into the current number until the current number is 1. If it's even, divided by 2. Skip B, draw it until it's 1. If it's even, divided by 2, draw it, done. Nice, we made it through the first example successfully. Let's try the second example really quick and make sure that it actually works. So we will start with 3. Display the starting number, okay. Display 3. Put put the starting number into the current number till the current number is 1. If it's even, divide it by 2. It's not. So we follow B. If the current number is odd, multiply it by 3 and add 1. 3 times 3 is 9, plus 1 is 10, and then display it. Okay, and then it's not 1. If it's even, divide it by 2, which it is, and then we skip B and display it. And then it's not 1. If it's even, divide it by 2. It's not, so we triple it and add 1. 5 tripled is 15, add 1 is 16, and display it. And then still not 1. It is even though, so we get to divide it by 2, and then output it. And then it's still not 1, but it is even, so we get to divide it by 2 and output it. And then it's still not 1, so we get to divide it by 2 and output it. And it's still not 1, so we get to divide it by 2 and output it. And we reached 1. And I think this program will actually work. And yeah, that brings us to the end of the first example. As you guys can see, if I actually wanted to turn this into code, it would be pretty straightforward for me to pretty much just go through this and say, hey Google, how do I figure out if a number is even in JavaScript? How do I multiply numbers in Python? And you should get really easy, really straightforward results, and you could string all the results together to recreate this procedure in any language you want and compute whatever collat sequence you wanted to. So let's take a look at a slightly more complicated problem that is going to require us to think at a little bit of a higher level, but I want to emphasize that this exercise will still work for those things. All right, so I've cleared our workspace from before, and the problem that I want to take a higher level look at is blackjack. And again, I want to emphasize that we're taking a higher level look this time. We're going to be breaking this problem up into smaller steps, but those steps are still going to refer to things such as decks and cards and players that no language has built in. The last problem we looked at got broken up into numbers and math operators, which every language ships with, but this time around, we're just taking a higher level look, and we're going to assume that we're given those things, and we'll talk afterwards about how to bridge that gap and how we would actually make this work in real life. So in order to play a game of blackjack, we need to be given a deck of cards and 2 players, which I'm going to call P1 and P2. We're going to be giving back who won. Player 1, player 2, or nobody. And then we have to run a few examples. So for anyone who's not familiar, blackjack is a card game. Both players are dealt cards face up, and then they have the opportunity to get more cards. The idea is that their cards should sum to as close to 21 as possible without going over. So we'll run probably 2 or 3 examples. So first one, we're gonna say that we have player 1 and player 2. Player 1 is dealt an ace and a 3. And player 2 is going to be dealt a 9 and a 5. So player 1 has a sum total of 14, and let's say that they get a 7. They now have 21. That is pretty much the perfect hand, so they take what they've got. Player 2 is also sitting at 14, and so they choose to hit. They get a 6, which is only 20, and player 1 wins. To run a second game, we might say that we have P1 and P2, and they both start off with the same cards as last time, except that this time, player 1, instead of getting a 7, gets a 9. So player 1 has busted. They've gone over 21, and they're ineligible to win. So even if player 2 only gets a 6, player 2 wins this time. Finally, we might play a third game, player 1 and player 2. And let's say that they both bust. So player 1 gets an ace, a 3, and a 9, and player 2 gets a 9, a 5, and an 8. They have both gone over 21, and there is no winner. Nobody wins. Everybody loses. Go home. Do not collect Go. Do not get $200. The house gets to keep the $200, actually. So yeah, with that, I think we're ready to start the procedure. So step 1 is going to be give player 1 and player 2 a card face up. We're then going to do the same thing, except face down this time. Step 3 is going to be until player 1, or actually as long as player 1 wants another card, give them another card. Step 4 will be the exact same thing, but with player 2. 5 is going to be compute the score of P1, store in P1 score, because again, any number that we want to reference in a later step needs to have a home and a name. 6 is going to be compute the score of P2 and store that in P2 score. 7, this is where we figure out if player 1 has won the game. So if player 1 score is less than 21, then player 1 can win. If player 1's score is, actually this is a less than or equal to 21, and if player 1's score is greater than or equal to player 2, actually we're just gonna go with greater than. We're gonna say if they tied, then nobody won. So if player 1's score is greater than player 2, then player 1 wins. And we'll do the same thing, but with player 2. So if player 2's score is less than or equal to 21 at this point, then if player 2's score is greater than player 1's score, or if player 1's score is greater than 21, then player 2 wins. And finally, if we got to this point, then nobody wins. And that's it. That, I believe, is a working procedure to play blackjack. I'm sure there's some quirks here and there that we could find if we actually ran through this enough, but I don't want to drag this video out too much longer. But the whole idea is that if we are given a deck of cards and 2 players, and we have the ability to give players cards face up or face down, as well as asking them if they want another card or knowing if they want another card. And we have to be able to compute the score of players and then compare numbers, which this is probably the easiest part. I think any programming language should be able to compare numbers. So as long as we can do all of those other things, we can play a game of blackjack. And at first, that's kind of a cop-out answer because there's not really any programming language that I'm familiar with that just gives you all of those things. But on the flip side, if we are choosing to implement this natively, like if we are just going to write this in pure C# or JavaScript, then at least we have a roadmap. We now know everything we have to do in order to finish building this game of blackjack, at least at a high level. And that's actually really valuable because as we build these things and as we invest time, then we can know how much closer to finishing this whole thing we are. And on the flip side, this is also a really, really important moment because unlike the developer that said, oh, I want to write blackjack, pulled out their C# terminal and just started thinking and writing C#, we have a second option available to us, and that is to strategically pick a language or frameworks that actually give us as many of these things as possible. So if we write this instead of in bare JavaScript, if we write this in a game engine like Unity, Unity kind of already knows what players are. And we might even be able to find a third-party library that knows what a deck of cards is. And if we pull those two things together, then we should be able to do these first couple things really easily. Computing the score might be a little bit harder, and that's where we would pretty much repeat this whole process. So we would start with, hey, I am given player 1's hand, or I'm given a hand, and I'm going to give back the score of that hand. And then boom, we can do steps 5 and 6, and then 7, 8, and 9, like I said, are just comparing numbers. So yeah. If we're gonna strike it out on our own, at least we know what we have to do and we have the roadmap. And if we are going to like really be flexible and open to using other people's tools and frameworks and libraries, then we can strategically pick a language in a framework that solves as many of these problems for us as possible so that we can pretty much just focus on building blackjack. And that is another really, really huge win for this exercise, is that it's a great way to organize your thoughts. And especially if you get stuck, this is a great way to figure out what you have to do to get unstuck. It'll either highlight what you don't know or tell you what you have to go figure out, or tell you what you have to go build if you do know those things. So yeah, my last recommendation to you guys is to find a database of practice problems that you can work through. Obviously, you're going to need problems so that you can actually work through this process on your own and actually write code on your own until you're comfortable doing both. And if you need a database, Project Euler is probably my favorite one. I recommend it to pretty much everybody. I'm sure you've heard it before, but math and programming kind of go hand in hand. And Project Euler is a database of practice problems that are designed to build those math skills at the same time. So they start off super easy and they get really complicated as you go. So find the ones that kind of fit into your skill level and go build 2 skills at the same time. They're totally free. I love that someone's out there doing that and I can't recommend them enough. But yeah, before we wrap up, I do need something from you guys. I need you guys to tell me what field of programming you want to go into, right? Are you learning programming so that you can go program robots? Do you want to go be a game developer? Do you want to be a web developer? What is it that you guys want to do? I think the next video that I build is going to be sort of a roadmap that takes you from where you're at today to there. And obviously I can't actually teach you all of game development in one video, but what I can do is sort of provide a roadmap of like, hey, here are the tools that game developers typically use, here's the programming languages that they typically use, here's the skills that they have, here's good ways to build and practice those skills. And if I could just do like a 60-second take on each of those different fields, I think that would be super useful. But I need to know from you guys what fields I should even cover in that video. So let me know in the comments. But yeah, hopefully you guys found this useful. I would also love to hear whatever feedback you guys have for me in the comment section, whether or not it was helpful, why it was or wasn't helpful, things I could do better, things I did good, whatever you guys have for me, especially if you watched it this far. Thank you for watching it this far. I would value your feedback a lot. But yeah, as always, have a great day. And if it's Friday, have a great weekend.